Thank you very much, and welcome everybody. It's a pleasure to be here, and in particular with my old colleague, I really have to say. We share some spots in the history because I actually took my thermodynamics exam with Detlef, and then we went both to RWE at one point in time, and so it develops. Now, pleasure to discuss a bit about energy technology, and if I understood our discussion, Veronica, correctly, it's also a bit in the sense of what does it mean in the logic of energy resilience in a more and more difficult world which we are today. And I would like very briefly only do an introductory talk, very generic, and obviously looking forward to a joint discussion on the subject of energy. For those of you who do not know us as a company, we are obviously active across the board of different generation technologies, from renewables to fossil, you name it, nuclear, in collaborations with others, but also on the grid side, which is the fastest growing business of Siemens Energy, which is growing roughly 25% year on year, which is enormous for a company like ours, which at the end produces things physically. And we also obviously are active in industry technologies like hydrogen, like finding electrification solutions for industry. So it cuts across different areas, but it's all about energy. And if you look on today, and I think this has been discussed here in multiple times now in the different sessions, obviously we find ourselves in a surrounding and world which is much more complex than we were actually used to, and very often we already heard it here discuss obviously the dependency on the supply chain, the mineral side. We very often discuss technology dependence. I think we underestimate the dependency on the financing systems by far. And particularly if you look on Europe, the fact that Europe does not have an integrated finance market is a big drawback for development here in the region, and difficult to understand why we not get that fixed. And obviously, at the end, it's also something changing what we see between competitors and customers. Obviously, first of all, it offers opportunities. A lot of competitors we collaborate with. We discussed, I heard about China before, right? Obviously, we have a lot of good collaboration in China and a lot of trustful relationships also. So China is not just China, it's very diverse in the picture. On the customer side, we obviously see more and more influence from geopolitics on customer behavior. And particularly if you're in energy, you recognize that you're in a very political business. And all of a sudden, you might have the best product, but the fact that you might be from the wrong country is a major problem in deploying technologies or winning projects. So that is the area where we find ourselves in and through what we have to maneuver. And if you talk about energy, it's also sometimes good to talk about some numbers. And probably that is an auditorium here who knows the things about it, but I still would like to highlight a couple of elements which I deem important on the point when we look on resilience. First of all, one thing is energy is growing going forward. It's a good and a bad thing, right? Because obviously it also means we have to do it in a way that is not too harmful for the planet. And we all know from current development that we are, in terms of energy needs and electricity needs, far beyond what we assumed during Paris. And that is obviously a challenge. The second point, if it comes to energy, is not only growing, electricity is overproportionally growing. And that is important in the sense of if we at the same time try to increase the share of renewables, it obviously means that overproportionally we must invest into grids. And that is something which is very often not very liked because people don't see that, right? You create an infrastructure, it costs a lot of money, it will require payback, it will increase prices. But fundamentally, it's an underlying infrastructure where not everybody is immediately aware that this generates value. But this is what we see globally everywhere. So that is, for us, a good thing because it drives our markets. But this overproportional growth of electricity is a big criteria if you now think about where do we develop systems to. The other point is obviously how is the mix of the different primary energy sources if you look on electricity. And I think we all have seen that renewables have developed tremendously fast. I'm sometimes struggling with the discussion in terms of are we going fast enough or whatever. If you look on the effective numbers, what is invested and how much gigawatt is added, it's a fantastic development if you see how fast the industry or the countries have deployed renewables into the different systems. However, we also have to recognize at the same time, this barely covered the growth at the end in the consumption system. So we didn't solve the problem at all, right? I mean, if it comes to CO2. But it is important, obviously, to recognize this also when we talk about the question of resilience and how dependent particular Europe or Germany is if it comes to primary energy sources. We continue to see renewables being the driving force behind the electricity additions. However, obviously, from our view, we discussed it before, gas will play a vital role in the transition. Nuclear will have its share to a certain extent, but to a limited extent from our view, and all will drive grid infrastructure. And that is obviously something which I believe today is underestimated. We today have a lot of discussions around data centers, and I have to say this year we roughly devote 50% of our gas turbine capacity, which we annually produce, only to data centers, only to the US. And that is obviously driven by a $650 billion investment program, which is done by the tech companies and the government and all the operators. We could easily sell all of our capacity to that market. However, we also have at the same time to see on a global base, if you see it in terms of electricity production, it's important, it's a driver for the market, it's a top up, it's something which not has been seen, but it's potentially only 5 to 8 or 5 to 10% of the overall electricity consumption. So while it is massively changing currently the investment climate, also because the tech companies have enough money to invest. Just as an anecdote, an installed gas turbine plant today costs roughly double what it used to cost 18 months ago. And it is paid, right? And that is something which changes substantially the picture afterwards of electricity cost also in the US. But I also would, let's say, be a bit careful. I mean, particular if you talk to financial markets, they sometimes believe today it's only about data centers. It's not, right? The basic thing is fixing the electricity supply in general and the growth. And then on top of it, you have an additional growth, which today we're struggling to serve, which comes from the data centers. But if it comes to resilience, obviously, one thing we all must be clear, the person who, or the country who wins the AI race, wins the resilience race. That is a defense question at the end, and that is why US does everything at the moment to allocate capacity for electricity production to the US. It all comes together, obviously, with investments, and this is why I'm saying we sometimes underestimate the role of the financial markets. And a non-integrated European financial market will disadvantage these investments tremendously. Much more important than the next new technology. If we do not get an integrated finance market here, I really see us struggling also to continue to drive things from here. What you also see is China by far is the largest investor, and that is not surprising. But what you see here also is China has been tremendously investing into the generation side in the past in anticipation what is coming on the AI side. So they are the front runner. A lot of this is coal, a lot of this is fossil, a lot of this is also renewable. But that is why the US is at the moment so eagerly investing into generation capacity, because they have recognized that they have underinvested into that capacity over the last decades and try to close this gap. That is the current picture. It obviously swings from year to year. So one question always would be, what does Europe mean in this area? Europe has been, and this is not so visible on a year-by-year comparison, Europe has been the biggest investor into the grid side. And I think that's a good thing. Europe has relatively early recognized the value of an integrated European grid, of connecting the countries in Europe, of keeping connecting UK to continental Europe. And in that regard, I would say Europe has the strongest base. We just don't use it accordingly. And obviously, if you talk about different energy markets design in the European Union, if you talk about how are you able to operate grids, what is your regulation around it, I do believe there is a massive potential which is today not captured. But by far, compared to other regions, we have overproportionally invested more into the grid infrastructure than other regions. It's a question now going forward what we do out of that. So when we talk about resilience, and we always were talking about the trilemma, obviously the key question at the moment is the fourth point, the resilience piece. And that is a defense question, that is a build-up question, but it really also brings a different element into all the discussion. And as I said, I see it at the moment in the US. We have more discussions at the moment about bring electricity whatever it takes at whatever speed, and I don't care what source it is, than to talk about sustainability. People are really having the concern that they don't get the electrons to drive their developments. And that is driven by a resilience view, by a defense view, which was not the case maybe 5 years ago. I couldn't come here without talking a bit about technology, even if I'm the industry representative, but obviously certain elements around technology. We are, as a company, investing around 1.2 billion euros every year in research and development. We do it across a relatively broad portfolio. And I just want to say a couple of words in terms of development on where we are on this journey if it comes to resilience. First of all, I think today we are still on the technology side relatively well positioned in Europe on the energy technologies in terms of availability, what is here in the region or even here in the country, from technology perspective and also from the factory footprint perspective. We are not very well positioned from a raw materials side. I think that's clear. But I think from the ability to manufacture something, we are not so bad. But we had to bring to lose certain things. And obviously, everybody knows the story about solar. Wind is still relatively well positioned. We are now just testing the next generation with a 250-meter rotor. So that is more than 2 times the span width of an A380, just to give you a feeling of what we're talking about as an offshore platform. But technology is available. Gas, what you see below it, established technologies, hydrogen use is not at the end the limitation of the technology. It's a limitation of the hydrogen. It's available. Lowest side, you see our collaboration with Rolls-Royce. That is, let's say, the footprint of a small modular reactor on the nuclear side, which we're jointly doing. By and large, the message here is generation technology we have available or under development. That's not a limiting factor. On the grid side, lots of activities happening at the moment to make it more decarbonized. You see on the upper side, it's a development which replaces climate harmful gases, SF6, by clean air. You see in the middle what is probably the most interesting field in grid, which is really the digitization and the sensors and the optimization of the grid infrastructure, because we will, from my perspective, not be able to physically build the grid infrastructure which we actually need for these electricity needs. We need to use our existing assets better. And on the lower side, it's development, I think it's actually from Aachen in a joint collaboration with the solid-state transformers. I put this there as a picture because when we talk about resilience, one thing we scratch our head is copper. And obviously, if you talk about transformers, you have a lot of copper in. That would be a technology which could relieve that. Not available yet commercially, but I think that is one of the big hopes for us going forward. And obviously the storage side, which will play in the grid stabilization and on how we manage the whole electrical system, play an enormously important role. We are here in the city where we have our hydrogen factory in terms of our electrolyzer manufacturing. It's still busy, but it doesn't look good in terms of the market because it's not a viable commercial case. But technology, by and large, is available. And obviously, on the battery side, it's more a question on pricing. I heard us talking here about Chinese coming to Europe as well. We continuously look into this, whether we also do something jointly there. But from a stationary energy side, there's also not really an interesting business case in this current environment. So to close it very briefly, I want to raise 5 points if it comes to resilience of energy systems. And it's all relatively trivial, but sometimes underestimated. The one thing is we need to learn that we design our systems for shocks. And this can be disruptions like we have seen in Spain, just because of the architecture of the design, but this can also be military actions. We are active in Ukraine by rebuilding it. And if you do not think through replacement at the beginning and how you do it and what happens if and how can you create islands that not the whole grid comes down at one point in time, you do something wrong. So keep failures local will be a key element of a system design in an energy system. And then how can you fast restart? Plan for the failure, but don't let it fail for 24 hours. And that is something which today in the system discussion is probably a little bit too little discussed. And the other thing is obviously standardize, standardize, standardize. It's very difficult to replace transformers if every component looks different. And that is the case very often today. And obviously, there's a lot of other elements if it comes to resilience, supply chains, material, and I think we will have enough opportunity to discuss. Thank you very much.
First of all, thank you, Veronica, and thank you, Christian, for that start. I can build on that, and I would like to take you in the next 20 minutes on a journey on pathways for the energy transition in challenging times. The word challenge has reappeared in most of our presentations here. That's what it's all about. And I will focus more on Europe and Germany. You were focusing more on the global perspectives. And I would like to start with something that you presented as a square. I have here the famous energy triangle in its original form. And security of supply was reliability and resilience. The other, I think, corners are known. The other corners are known. Oh, that's a good point. Thank you. Yeah. We have climate, environmental protection. We have economic competitiveness. We have security of supply. And whatever you put at the top, you will be criticized, I guess. This time I put climate, environmental protection to the top. But all of these are unfortunately often in competition with each other. Not always, but often, and they need to be balanced. As we know, we thought in the beginning, like the US today, it's only we need electricity at whatever cost, we just need it. Then it's we need it economic at competitive cost. And then later in Europe, etc., in the 70s, 80s, 90s, the topic of climate and environmental protection started. And now many put in acceptance, because without acceptance or acceptability of the measures, it just takes forever. It will be very, permitting times will be long, it will be very costly, and so I put that in and also will focus on that. Right, and along these dimensions, I've now tried to map out the highlights of where we stand in the current situation, with pluses and minuses, as you can see here in the beginning. So, climate environmental protection, first one, as you already mentioned, greenhouse gas emissions reduced by 48%, Germany now, since 1990. This is a lot. The 2020 goals, we didn't think we would achieve that, the 40%, COVID helped, but we are still on the pathway down. But on the other hand, 65%, I mean, we've done 48 in 30 years. Now we have 5 years to reach another 17%. This will be hard, but we are on the way. So I gave it a plus. Second one, share of renewable energy in electricity generation, now even up to 59%. Goals for 2030 is 80%. If we stay at 450 terawatt hours in Germany, which is lower than a couple of years ago, we might reach it, but we all think, of course, electrification will finally take off, so that will be hard to reach. Anyway, it's also a plus. Share of renewable energy in mobility and heating. That doesn't look too good. Here is in electricity, share of renewables 2023, now approaching 60%. In heating, it's 19%. In mobility, it's 7%. And of course, you think this is heat pumps and this is electric mobility. It is not. This is E5, E10 mostly. This is pellets in heating, which are environmentally so-so, you could say. So electricity here only, and renewable electricity makes up for only a little bit. So that is definitely a minus. So lagging far behind. And of course, the long permitting times and lack of workforce. That's another topic. FAZ a couple of years ago titled, "We need 1 million more experts to really realize the energy transition." 1 million, that is lacking. Slowing down the transition and leading to higher cost. Next topic, economic competitiveness. Well, there is lots of minuses. Electricity costs have almost doubled since 2010 and are among highest in the EU and world. That has been mentioned by many of you already. And here is a chart taken from the BDE, from the German Industry Association, what's done by BCG, I think, which shows that from 2010 to 2024, actually the specific electricity system costs have doubled. Main drivers, new renewable energy, because we built so much, of course, but also grid expansion. Grid costs for households have doubled in the last 6-7 years. From like 5 to 6 cents to now 11, 12 cents. You said we need a lot of grid, but grid costs have doubled for households. That's really a lot. There is also higher energy prices, including the CO2 burden, of course, ETS, but also the higher gas prices that we now see after the Ukraine crisis. This is 2024. Demand reduction was a big driver. If the denominator is smaller, then specific costs rise. So, I mean, we used to have 550 terawatt hours, now we have 450, despite the desired electrification. That is industry going down, that is also photovoltaics at home, Balkonkraftwerk not feeding into the grid and not taking their share of the cost of the grid. We need to discuss that, and it's being discussed, and other effects. So that is negative. And then natural gas prices, not competitive anymore. Doubled since 2021, factor of 3 compared to the US. This is not, well, even if we went to natural gas and didn't go to hydrogen, it would be a big problem. Hydrogen, foreseeably substantially more expensive than hoped. 5 to 10 times the price of natural gas, even in the longer term. I will come to that later again. Security of supply, again, some pluses, fortunately. Reliability of electricity supply still very high. Only 13 minutes of lack of service per annum. That is among the world best. We are the most expensive, but here this is really good. And also the dependency from oil and gas imports is reducing with more and more renewables installed in Europe and in Germany, while at the other side, import dependency of critical parts, as we've heard, especially photovoltaic modules, batteries, 80% of that is manufactured in China. That is a dependency that we've also talked about. Finally, acceptance, the bubble in the middle. The support for energy transition is still high, but we have NIMBY, not in my backyard. And this is a chart here, which was from 2018, 90% supported the energy transition. This, unfortunately, is down now to 68%, but still support. Acceptance of wind plant in neighborhood, not accept is, well, more than half. This has risen. More people, more than half of the people say, well, yes, in 3 kilometers away, I would accept a wind farm. That was quite surprising, so that has improved a little bit. While overhead lines in the vicinity has gone down, everybody wants underground cables, not knowing that they are 5 times as expensive. It's a problem. So, and then electricity cost in 2018, 78% were concerned about higher electricity prices, rightly so. They have risen, and nobody really knows and understands by how much it has risen because of the energy transition. There was another sub-poll here saying that only 5 or 10% of the population would accept more than 150 euros per annum of higher energy prices to support the energy transition. If you really count it, now we're already at about 1,000 euros more than we were before the energy transition, if you account for everything that is in there, CO2 costs and grid costs, etc. But we know we have to do it. So that was some bad news, but there is also lots of good news. The good news is the pathway is known. And I've myself, in the last 20 years, I've participated in many of those system studies on how to reach climate neutrality in 2050 with at a least cost approach. So, and the experts, I think most of the experts and the studies that were done by BDE, by AKTech, by DENA, they converge. It is the same messages that you have, what should be done. And in a very simple manner, I've tried to list here the measures, the big measures to be taken in an order of rising complexity of conversion. So I start with energy saving, where you don't need any energy conversion. You got safe, you just don't do things anymore, like driving, flying, whatever. And it ends here production and use of green fuels, H2 or ammonia or green methanol or whatever, and the steps in between. So if I can, and it ends with something that we will definitely need, and I say it here already, CCS and negative emissions. IPCC says that we need that. Big discussion still going on, skepticism in Germany. We will need that to reach the climate targets globally. So, energy saving, change of consumer behavior. Many bet on it, everybody hopes for it, but don't rely on it. It doesn't happen. Secondly, increase of efficiency. Everywhere it is happening. That's why also electricity demand is going down to improve steadily in industry, everywhere you go. That is a big lever. Direct use of renewable energy without renewable electricity, so biomass or solar heating or geothermal or whatever. Yes, there is some potential in heating, but it's limited. Also biomass is limited. Then the biggest, by far the biggest lever at the moment and the most competitive lever, generation and use of green electricity. That is, so electrification, so build as much renewables as possible, wind and solar, and let all the cars drive with electricity, and in the longer term, heat with electricity, etc. Use electricity wherever you can, because H2 is unfortunately much more expensive than we thought, and there are other reasons not to use H2 too early. I will come to that later. So needed but expensive only if this is impossible. That sort of a little bit with my emphasis from the studies. Okay, that is one good news. We know what to do. Unfortunately, it's not done that way always. The next good news is electricity cost of wind and PV today is already much lower than fossil fuels or nuclear, even in Germany. This is from Fraunhofer, an update that they have every year. Here is PV roof, PV ground-mounted, wind onshore, wind offshore. It's all between like 5 and maybe 10, 11 cents, except for small rooftop PV. But the large plants are all around 5 to 6 cents per kilowatt hour. Compared to that, well, biogas is more expensive, solid biomass. New lignite plants, new hard coal plants, new CCGT, GOD plants are more expensive. I have to say CO2 of about 80 euros is included in that. Otherwise, it would be somewhat lower, but it would not go below 10 cents. So new plants, just the electricity production is really competitive here and much lower, and especially much lower than nuclear, although Trump might say differently. Nuclear, somewhere, it would be a surprise if France built it for under 15 cents per kilowatt hour. I doubt it from all the projects that are going on. Yes, and even what is interesting here with battery, even PV ground-mounted with battery. In sun-rich states, this would be a baseload plant, can be operated 365 days, 24 hours. Even in Germany, that is, well, somewhere here between 7, 8, 9 cents. In sun-rich countries, it's under 5 cents already. That would be baseload plant, battery, and solar. So that is a good news. Is there more good news? Well, so build renewables and electrify, and that is being done in the world, as like Christian has also pointed out, and others have. I just read, in 2023, more than 530 gigawatts of renewables were added globally, with China's share rising to almost 60%. So more than half of all renewables are not only built, manufactured in China, but are installed in China, number one. 80% of all PV, 80% of all batteries are manufactured in China. 60%, as Mr. Hiesinger was pointing out, of electric cars are manufactured in China. 60% of all cars manufactured, and So, and then I was wondering, okay, so many renewables, they are really a role model, and electric cars, so they want to reduce CO2, and now they want to until 2035 by 7 or 10% even, which was a surprising news. But at the same time, they inaugurate one new coal plant a week. So how does that go about? Yeah, still coal. And then I thought, well, it's what we are talking about, one of the main topics of our conference here, resilience and autarky. They have cheap coal, they have cheap renewables. Coal as backup of renewables makes a good combination, has CO2, yes, over time it will go down, and they become, with electric mobility, they become autonomous and autark from oil and gas imports, because they don't have oil or gas. Oh, okay, 2 minutes. Did you shorten my time?
No.
Okay, all right. Then I will, yes, we can. This one we already had, this is battery development. Yeah, the cost of batteries, Yannick, you did it. And so I come to my last 2 slides, that is good. And in the sake of time, I will just read them to you. These are some thoughts on way forward in challenging times. I thought this would be easy. I've participated in all those studies, so just write down what has to be done. But then I put I put myself in the position of a politician, having not only to do it at the least cost, but win acceptance, resilience, etc., etc. And then it became really difficult. So we complain a lot about politicians, but it's really difficult what they have to do, because they have to consider the long-term prosperity of a country, but they want to be elected again, etc., etc. It is really difficult, but I still came up with a few things that I will read out to you. First, employ an 80-20 approach and a system view with a focus on implementing measures which are impactful and cost efficient. For example, employ monitoring of CO2 abatement cost as a key tool for orientation. Many is negative already, so it's competitive. H2, hydrogen, in most applications is more than 500 euros per ton. Also insulating houses, if they don't need to be insulated from a deterioration standpoint, more than 500 euros per ton, so don't do it too quickly. Others are much better, so that's a very good tool. Continue expanding rest-based electricity generation, wind and solar, drive electrification, as I said. Expand electricity grids cost efficiently. Hopefully we will do that and strive for high utilization. That's what you said also. Use natural gas and blue hydrogen as long as green hydrogen is too expensive and not really green. Many know it. We've talked about it with several of you. Just very quickly here. If we produce hydrogen today in Germany or Europe, it is much worse than natural gas. Only if you reach 90% and more of green electricity, then it becomes better than natural gas. So if we turn to hydrogen too quickly, we will not only get more expensive, but also do harm for the environment. Well, okay. No, that was a long one. This is the right one. Reflect real cost and prices for market and system-oriented behavior. Carbon pricing, I like it. It will be expanded, the ETS 2 and 3. Develop capacity markets for electricity generation backup. That is being done. Ms. Katharina Reiche talked about it. Let's see how it goes. Make electrification of heating and mobility more attractive by lowering kilowatt-hour price, and expand dynamic pricing to ensure optimal usage of grid and rest generation. Now the last one. Enhance resilience and flexibility of the energy system. Tender load CO2 backup power plants. We will need more than 20 gigawatts. We're always talking about 20 gigawatts. We will need much more. Technology open, of course. Employ stationary batteries and batteries for battery electric vehicles, vehicle to grid, etc., for system stability, etc. Explore potential of hybrid heating systems. Where we have gas, install a small heat pump, yeah? Then you don't need to do the house all new, and later on, when you have to do it, then you can switch to electric right away. Build partnerships, connectivity on a European and global level, including the MENA region. I was very much involved in the Desert Tech project. I still believe in that. It is good. It went down for other reasons, but I still believe in that. We should expand connectivity within Europe and to North Africa. continue to diversify sourcing of gas, including blue hydrogen, explore and develop CO2 storage, there's lots of it, and build consortia for CCS and negative emissions, and develop a compelling narrative and a fair distribution of burdens. This is what I wrote down. And now I have one last comment for 20 seconds, because I came up with 2 additional ideas, which have to do with the market design. And I think that is very important. This will not be enough to ensure economic competitiveness. It's good, it's all good measures, yeah, but it will not be enough to reach the levels asked for by Wacker Chemie and others. So we need to do radical steps thinking out of the box. So one thing is, on the generation side, maybe our merit order system, where the last power plant sets the price, has to be reviewed. Because it could be that 90% of all electricity is done by cheap solar and wind, and still the price at the stock market is very high because a gas or H2 plant sets the price. Yeah? So then wind and solar will earn trillions, yeah? Exaggerate a little bit, but the price would be high. Maybe we need to think about that again. Number 2, the grid. Why don't we do it like with German Autobahn, yeah, finance it completely through, because it's infrastructure, like the train system. It's infrastructure. Why not finance it by the state as some basic amenity, yeah? And then we could reach the levels that are necessary for Wacker. But we have to take out grid, because grid now is already 12 cents and it will go higher. For industry, not as high, but it will be a problem. So that might be some radical thoughts for our discussion. Thank you.